Layers of caching in Jakarta persistence. Here you can see layers of caching in Jakarta persistence. If there is one thing we can, now we are going to shorten through caching the layers. If there is one thing that we software types like to do, it is a break things down into layers. We do this because dividing a complex system into multiple cohesive pieces helps us to more easily understand and communicate aspects of the system, because it works pretty well, and we are not ones to ignore a good thing. We will similarly partition the Jakarta persistent architecture into layers to illustrate component different opportunities to cache. This figure gives a pictorial view of different caching layers that might exist. First layer we encountered is actually the application tier. Any application might be written to cache as many entities as it liked, simply by holding into references to them. This should be done with the realization that entities are likely going to become detached at some point, and the longer they sit in application space, the higher probability they will become stale. Application caches have their place, but are generally discouraged because the cached entity instances will never be included in any future Jakarta persistent query results or persistent context. Next, the persistent context referenced by the entity manager can be considered cache because it keeps references to all managed entities. If as it is done in hardware architectures, we categorize the different layers of caching into levels. We would call the persistent context at first revealing Jakarta persistent caching, because it is the first place that the persistent provider could retrieve in an in-memory entity form. When running in a transaction scope entity manager that has a persistent context demarcated by the transaction boundaries, the persistence context can be termed a transactional cache because it is around only for duration of the transaction. When entity manager is an extended one, its persistent context cache is longer lived and will go away only when the entity manager is cleared or closed. Executing find method or query method can be thought as loading one or more entities into the cache while invoking detach method on the entity that can in some ways be considered the persistent context cache eviction of that entity. The difference is that if there are pending state changes in that entity, they will lost unless a flush operation occurs before entity is detached. Caching in entity manager caching in entity manager factory is referred to by some as the second level cache, but of course this name makes sense only if there are no caching layers between it and the persistent context, which is not the case for all providers. One thing that is fairly prevalent across all providers is that the entity data in this cache is shared across entity managers from the factory that contains the cache. So the better name for it is shared cache. This cache has a specific API associated with it and is yep. And the last cache that can contribute entity state to Jakarta persistence is the JDBC cache drive. JDBC driver cache. Most drivers cache connections and statements. Some caches keep the track of the table or column state that is essentially transparent to the Jakarta persistent provider, but that nonetheless can offer some saving in terms of not having to go to the database to get data on every call. This is generally feasible on the driver only if it is known that either data is read-only or driver controls the database access exclusively. Note some providers such as Eclipse Link and Jakarta persistent compatible implementation provide much more sophisticated and exotic caching layers and features such as isolated caching or virtual private database VPD, support line gain options to determine automatic entity eviction policies and distributed cache coordination mechanisms. Many also offer integrations with deluxe and highly specialized distributed caching products. To see how various levels of caching in the system get accessed during the course of typical operation, you can see the you can go through some code segment with find requests. To see how the various levels of cache in the system get access during the course of typical operation, is trace a find request for the employee ID with ID 100. First thing that happens is that the client looks in its total cache, local cache for the employee and finds that it doesn't have the employee instance with ID 100. Then it issues the find calls to the entity manager. The entity manager will likely have the persistence as context associated with it. So it checks its persistence context for the entity of type employee with ID 100. If the entity exists in the persistence context, the managed instance is returned. If it does not exist or no persistent context had yet be associated with the entity manager, the entity manager goes to the factory we'll go to the factory to see if the shared cache has the entity instance. If it does, the new employee instance with ID 100 is created from the shared one and inserted into the persistence context, and the new managed instance is returned to the caller. And if it does not in the shared cache, then an SQL query is generated to select the entity from the database. The JDBC driver may have some data cache, so it could short circuit the select clause and return at least part of the needed data. The resulting query data is then composed into an object and passed back. The object is inserted into the shared entity manager factory cache, and a new instance copy of it is created and inserted into the persistent context to be managed. That entity instance is finally returned to the client application for the client to cache if it is so inclined. So here you can see the application cache is inside application, and application interacts with the entity manager and entity manager factory. Persistent context is inside entity manager, and entity manager interacts with the entity manager factory. Shared cache is inside the entity manager factory, and entity manager factory interacts with JDBC driver, and table or column caching is inside JDBC driver. JDBC driver interacts with database. Now this is the end of my presentation. Thank you very much for watching it.